Ever wondered how to tell if an alcohol is primary, secondary, or tertiary in the lab? It is a classic problem. But German chemist Victor Meyer came up with a beautiful color test in 1887 that solves this in just a few steps. This elegant method gives a different, vibrant color for each type of alcohol. Today we will master it completely so you can ace this question on your NEB exam. Let's begin. So, who was Victor Meyer? He was a famous German organic chemist. The purpose of his test is to distinguish the three classes of alcohols, 1 degree, 2 degree, and 3 degree. It works by a characteristic color change at the very end. The reagents we will use are red phosphorus and iodine, then silver nitrite. After that, we use nitrous acid, which is made from sodium nitrite plus HCl. Finally, we add sodium hydroxide. It's 3 chemical transformations, 1 color observation. Let's start with step 1, convert alcohol to alkyl iodide. The reagent for this is red phosphorus plus iodine. These react in situ to form phosphorus triiodide, or Pi3. The general reaction is R-OH plus red P plus I2 gives R-I plus H3PO3. This first step works identically for all 3 alcohol types. For example, propan-1-ol, which is primary, gives 1-iodopropane. Propan-2-ol, a secondary alcohol, gives 2-iodopropane. And 2-methylpropan-2-ol, a tertiary alcohol, gives the corresponding tertiary iodide. No differentiation happens here, yet all 3 alcohols react. Now for step 2, convert alkyl iodide to nitroalkane. The critical reagent is silver nitrite, formula AgNO2. Remember, not silver nitrate. The general reaction is R-I plus AgNO2 gives R-NO2 plus AgI. Silver forces the nitro linkage, a CN bond, rather than the nitrite ester ON bond that sodium nitrite would give. Now we have 3 different nitroalkanes. Primary alcohol gives a primary nitroalkane, R-CH2-NO2, with 2 alpha hydrogens. Secondary gives R-CHR'-NO2 with 1 alpha hydrogen. Tertiary gives R-CR'-R'-NO2 with 0 alpha hydrogens. Remember this alpha hydrogen count, it matters for the next step. Step 3, react the nitroalkane with nitrous acid, HNO2. Nitrous acid is generated in situ from sodium nitrite plus dilute hydrochloric acid. This is the key differentiating step. It requires alpha hydrogens on the carbon bearing the nitro group. For the primary nitroalkane with 2 alpha H, it reacts with HNO2 to form nitrolic acid. The structure is R-C with a double bond to NOH and a single bond to NO2. It has a yellow color at this stage. For the secondary nitroalkane with 1 alpha H, it reacts with HNO2 to form a pseudonitrol. The structure is R-C with a single bond to NO and a single bond to NO2 and another R' group. This is already blue at this stage. For the tertiary nitroalkane with 0 alpha H, no reaction occurs. The nitroalkane just sits there unchanged. So differentiation happens before we add the base. Step 4, add aqueous sodium hydroxide to each solution and observe the color. For the primary alcohol, the nitrolic acid forms its sodium salt, producing a beautiful blood red color. For the secondary alcohol, the pseudonitrol gives a characteristic bright blue color in base. For the tertiary alcohol, since no reaction occurred in step 3, the solution remains colorless. The unreacted nitroalkane is essentially colorless to pale yellow. Here is your easy mnemonic to remember forever, RBC for 1-2-3. R for red equals 1 degree. B for blue equals 2 degree. C for colorless equals 3 degree. Or you can memorize it as red 1, blue 2, clear 3. Easy. Let me solve one NEB-style question. Question: an unknown alcohol was subjected to Victor Meyer's test. On addition of sodium hydroxide, the solution turned blue. Identify the type of alcohol and give one example with structure. Solution steps: first, the blue color means secondary alcohol 2 degree from our mnemonic. Second, a common example is propan-2-ol, structural formula CH3-CH with an OH group -CH3. Another is butan-2-ol. Third, we explain why it's blue. The secondary nitroalkane has one alpha hydrogen, which reacts with nitrous acid to form a pseudonitrile intermediate. That intermediate gives a blue color in base. Final answer, secondary alcohol, example propan-2-ol. Quick mnemonic recap: red equals 1 degree, blue equals 2 degree, colorless equals 3 degree. RBC for 1-2-3. Exam tip: Victor Meyer's test is frequently asked in NEB as either an identify the alcohol or explain the mechanism type question. If this video helped, hit subscribe and like. Drop a comment telling me which test you want next. Coming up soon, the complimentary Lucas test for alcohol classification. See you there.